So in this video, I want to add another feature to our model to predict win rate on top of the on-base percentage difference. And this is going to be our example of multiple regression because now we're using multiple features in our regression model. And so in addition to the on-base percentage difference, I chose slugging percentage. And so why did I choose slugging percentage? It was actually a battle between multiple features to choose. You could have chosen either of these really, and it would have made very little difference, but I chose slugging just for the sake of you can also choose batting average, but why did I choose slugging and why would batting average also work? Well, first off, whenever you're adding a new feature to your model, you need to ask yourself two questions. Is this feature linearly correlated with the variable I'm trying to predict, which is the dependent variable? In our case, that's win rate. And so we need to ask, is slugging percentage linearly correlated with win rate? If we look at slugging percentage, it looks mildly correlated. If we look at on-base percentage, it's also mildly correlated. If we look at batting average, it's also correlated as well. And so those three predictors are correlated. Runs scored is correlated as well. All of these are. But so all of these are somewhat correlated. Obviously, these more than others. So that's the first thing. Is it correlated with the predicting the variable we're trying to predict? Second, we need to ask our question, is it linearly correlated with any other feature in our model? Because what we don't want is we don't want it to be linearly correlated with the feature we're already using, because then we would be introducing what's called multicollinearity into our model, where a feature is correlated with another feature, and that's bad for our model. It affects the size of our coefficients, the parameters that we learn, and it also affects the accuracy of our model. And so we're trying to find a feature that's not linearly correlated with on-base percentage difference. And so if we look at on-base percentage difference, it's linearly correlated with the slugging difference, so we can't use that. It's pretty correlated with runs scored here. This is looking pretty correlated, so we can't use that. It looks to be pretty correlated with on-base percentage, but maybe we can get away with that. But it's not correlated with these. And maybe you could say that runs scored is useful. I wouldn't mind runs scored too much. But I would say maybe it's a little too much. But try it out. Maybe it's better. But these right here, especially batting average and slugging percentage, they look like they're not as linearly correlated. Slugging percentage a little bit, but we could give them a try. Let's give them both a try. And so I'm gonna go all the way down here, and I'm gonna go to here, and I'm gonna try slugging percentage. So we're trying to see if it improves the accuracy of our model. And so on the test set, we got around 0.80. And so let's run this again. And so this is on the training set. And then let's run it on the test set. We got 0.819. So we went up to 0.819 on the test set. And to show what we do when we have multiple regression models is we actually, instead of doing R squared, because that was the R squared on our test set, we do adjusted R squared. And our adjusted R squared was 0.815 on the test set. So adjusted R squared is actually going to adjust our model and penalize it for adding that second feature. And so as you can see, we got an improvement in the test set score when we added that second feature. And then if I plot the relationship between the predicted and the observed, you can see it's a lot tighter. This is for the training set. And then if I were to do it for the test set, you would see it's a lot tighter as well. But we actually got an improvement. We added another feature to our model. Try batting average. Try using that one. And we got an improvement in our model's performance. Now, I would like to say that, unfortunately, in this notebook, I forgot to add a random seed. And so a random seed is going to allow for me to get the same results every single time. It was an error on my behalf. And so if you run this notebook, you're going to get different results than me. But I just want to warn you of that and be honest about it. The thing is what you're trying to look for is not trying to replicate my results. What you're trying to replicate is an improvement in the model's performance whenever you add another feature. And so when you run this and you add that second feature, you're trying to see the model's R squared, adjusted R squared, go up. when you add that second feature. And so just wanted to point that out. Adding more features to your model can make it perform better, and it can be worth adding complexity.